Hi guys, today I'm going to be working through the next type of graph from our Year 12 graph shapes review, and I'm going to be working on hyperbolas. So we're not covering absolutely all graphs, but we'll cover the main ones. So look, first let's look at the special features and what we need to be super careful of in a hyperbola. So we have, of course, the shape when we're drawing it. We have the y-intercept, we have the x-intercept, and our special feature is that we have asymptote. So in a hyperbola we're going to be dealing with asymptotes. So look, something that we need to look out for in a hyperbola is when we have something like this, y equals 1 over, say, 3x plus 4. So when you do this, you're going to need to remove whatever's in front of the x. So you would then have y equals 1 over 3 and x plus 4 over 3. So this is really important. Keep your eye on that. So I might change that example heading to be careful. So anything that is in front of the x needs to be removed before you can view your asymptotes correctly. So look, let's use that same example there, and I'm going to write it as y equals 1 over 3 x plus 4/3. And actually I might just add on to the end of that minus 3. So minus 3. There we go. And look, the general shape of a hyperbola is going to be like this. So there's our axes, and our graph would be like this. So what we see there is that it's asymptoting about the x and y axes. And our equation for our parent graph would be y equals 1 over x. So just like I did for the parabolas, I'm going to color code all the different transformations that we apply as we draw this graph. So starting with yellow, the dilation, and dilation is something that we multiply by. So in this case there's a 3 and it's in the denominator, and that's okay, we still can show it. So it's going to be y equals 1 over 3x. And look, for the purpose of sketching your hyperbola, or really any graph where you're going to be showing x and y intercepts, it doesn't really matter too much about the dilation, because that's going to come out when you find your intercepts. You're going to have values that are different if you have a different value for the dilation. So if we didn't have that 3 there, our graph would look different and our intercepts would be different to if we do have that 3 there. So look, I'm just going to draw, it's still here, and I'm going to go to the reflection, and in this case we don't have a reflection, so I'm just going to leave that blank. If there was a reflection, it would be a negative. So we'd be multiplying it by a negative in some way. So I'm not going to put that there because we're not going to do a reflection this time. If we did, it would be multiplying by a negative, either in the numerator or denominator or out the front, which is the usual case. Horizontal. So the horizontal, as I wrote last time for the parabolas, it goes in the opposite direction and it's connected to the x. So here we see that this positive 4/3 is connected to the x, it's in brackets with the x, and what we're going to do, we're going to be going in the opposite direction, so we're going to go in the negative direction by 4 on 3 units. So originally our asymptotes, as we said, were on the x and y axes, so it asymptoted on those axes, so we could say that they were at x equals 0 and y equals 0 respectively, but now we're going to go in the negative direction by 4 on 3 units. So we're going to move this asymptote over, and this is going to say x equals negative 4 on 3. And then we can draw our hyperbola in the same way. So our equation here is going to be y equals 1 over 3x plus 4/3. And notice how this is very different to if we had forgotten to remove this 3. So in the be careful step, if we had not removed the 3, you would very easily think that this asymptote would be at x equals -4. It's absolutely not at x equals -4. So it's really important we remove whatever's in front of the x from everything in the denominator there. So look, we've nearly built up the equation the full way. The only leftover thing is the vertical shift. And the vertical shift is the thing that's not connected to the x. So it's not in brackets with the x, and we move in the same direction. So again, when you do transformations with mapping and matrices, you will understand why that is. So building upon what we had previously, x equals -4/3, and then the y value, I'll just go back and check, was -3. So now we're going to move our asymptote down to y equals -3, and then we can draw the hyperbola in. And this is the place where, you know, you might like it to wait until you've got your intercepts to draw your final graph, because I mean it could look like that, but it also could look like that. So it could be that we get a positive x and y intercept rather than the negative. But look, I'll leave the red one there for now, and we'll see what that actually becomes. To finalize it, I'm going to write the whole equation there. Oops. And we can see that we have addressed every part of it. We've addressed the dilation, there was no reflection, and we've addressed the horizontal and vertical shifts. So now that we've done that, let's find our intercepts. So I'm going to start with the y-intercept, because y-intercept is usually easier. So y-intercept when x equals 0. And you can use this equation, or you can use the one before we remove the 3. And look, I'm going to use the one before we remove the 3. 3x plus 4 minus 3. So we're going to get y equals 1 over 3 plus 4 is 7 minus 3. And look, this is quite nice because it means I've drawn my my y-intercept and x-intercept for that matter in the correct places. They will both be negative. So it's going to be 1/7 minus 21/7 equals -20/7. So -20/7, that's my y-intercept. And now I'll do the x-intercept. So of course when y equals 0, so let's do 1 over 3x plus 4 minus 3 equals 0. 1 over 3x plus 4 equals 3. I'm going to multiply by 3x plus 4 on both sides. I get 3. 3x plus 4 equals 1. I'm going to expand. 9x plus 12 equals 1, minus 12 on both sides. And then x is going to equal -11 on 9. So my x-intercept will be at negative, oops, I wrote that a bit weird, 0, -20/7, it should be, of course. And then the x-intercept, -11 on 9, comma 0. So now that I've got those, I'm just going to redraw my hyperbola and put in all those features. So we can see it a little better. So the first thing I had was an x-asymptote, which was at -4/3. And you want to label the asymptotes. I had a y-asymptote at -3. So by labeling the asymptotes, I mean like label the equations of the asymptote, so that and that. And then, well, now I have my hyperbola looking like this. So -11 on 9 and 0, -20/7. And then we have it. So the big ideas there about the hyperbola, we have the asymptotes that we have to label with their equations, obviously the shape, and of course this one needs to go in as well, the shape of the asymptote to recall, but the thing that a lot of people will forget is this part here. So to remove whatever is in front of the x before you choose your asymptotes.